Okay, this is problem 62 from chapter 7. Hopefully you can kind of see it, but we have this block in between these two springs. We're given that one spring has 25 newtons per centimeter force, and the other one has 20 newtons per centimeter of force. The block is 3 kilograms, and the block is pushed 15 meters to the right, and it's wanting to know what is the, let me make sure, what is the maximum speed of the block? Because it's pushed over there and then released, it wants to know the maximum speed. So to know the maximum speed, we first need to know the total potential energy of this system. And so we're using PE equals 1/2 kx squared, and we can plug in for both of these springs to figure that out. So I'm going to say PE1 equals, we're doing this 0.5 times, let me just write it all out so that you can see. Okay, so I'm doing this for both of the springs. The first one is for the spring with 25 newtons per centimeter. The second one is for the 20 newtons per centimeter. If we plug everything in, for the first one, this is 2,812.5 newtons per centimeter, and the other one is 2,250 newtons per centimeter. Now we're just gonna find the total potential energy between those. Which is about 5,000. It's about 5,063 newtons per centimeter, but we want it to be in meters, so we're going to divide that by 1,000, or by 100, sorry, to get 50.63 newtons per meter. Like that. Now, we want to solve for the velocity, and we're going to be using the kinetic energy equation. Let me make a little bit of room here. So we have 1/2 mv squared, and we're going to plug in, or sorry, we're first going to solve for v, because that's what we want. When we solve for v, we get the square root of 2ke over m. And then we'll plug in. So we solved for v, we plugged in 2 times our potential energy, or kinetic energy total, divided by 3, and we got 5.81 meters per second for v. That's the max speed. Yep, that's the max speed. And it says, where in the motion does the max speed occur? It occurs when all the energy is kinetic. So this would be when x equals 0 in this equation. asks us, what is the maximum compression of spring 1? So the max compression is equal to the maximum elongation of K1. So the max compression would be the 15 centimeters, or 15 meters. Oh, centimeters, sorry. The maximum compression would be 15 centimeters. That could be implied onto the first spring. Hopefully that makes sense looking at this. And that's it.